Hey guys, Mr. Corbin here again with Miss Powell, and this is video number 2 on reviewing rational and irrational numbers. And we're actually, Miss Powell, going to order these rational and irrational numbers on a number line. And so to do that, we're going to have to do some approximation, which we already did with the sheet and the numbers that you gave us last time. So, Miss Powell, what do we want to do here with this number line?
Okay, well, the lesson that we did before, we said whether the number was rational or irrational. And what you need to understand is that no matter what the number is, what type of number it is, you can always place it on a number line. Now, to place it on a number line, though, if they had asked me to put square root of 14 on the number line, I really don't know where that would go until I turned it into a decimal representation. So if you'll change all your different types of numbers to a decimal representation, that will help you figure out where that square root of 14 would fall.
So this is really important, guys, because if they give you a list of numbers, a lot of times they're in fraction form, they're in decimal form, they might be mixed numbers, they could be anything. And so to be able to order those on a number line, rational or irrational, we want to turn them into decimals. And of course, the decimal approximation is what we come up with for those irrational numbers because they're non-terminating, non-repeating decimals. But like Ms. Powell was showing you on the paper just a second ago, and she's going to show you again, those decimals, we can, when we get them into decimals, we can now order them on the number line. And so, Ms. Powell, where are we going to start?
Well, the square root of 14 is decimal representation. We're going to just round it and estimate it to be about 3.7. So if it's 3.7, then you know that it's going to have to fall between 3 and 4. It's bigger than 3, but smaller than 4. So then I try to get it, which if you have a huge number line, you can estimate a little bit bigger or better.
You don't like my number line, Ms. Powell?
It's kind of squished.
Ms. Powell,
so,
this is the best number line we could come up with. You know this.
So
it might be a little squished.
Yeah, it's a little squished. So 3.5 would be exactly in between 3 and 4. So you need to put it a little bit past the 3.5.
Okay.
Since your number line's squished, it's going to look about at 3.5 anyway.
Okay, so Ms. Powell, I am trying here, and it's going to be about right there. So not great, but close. And so this is
square root of 14.
Square root of 14. And so we talked about this. You can put this above or below the line. I'm going to put it down here below the line. And so that's the square root of 14. Okay?
So the next number that we maybe want to do is to put the square root of 156 on the number line. Now again, that's not normally how you're asked. But if you go and you look at the decimal representation, it is irrational. So I can't have a fraction, but I'm looking at the decimal anyway. It's 12.489996 ... So we're going to round this and say it's pretty close to 12.5, just a little bit less than that.
Right. And so again, this square root is an irrational number because it's not a perfect square. So it is an approximation. So 12.5, here's 12. And so I'm going to try to hit it really close. And I changed the color for you there, Ms. Powell.
Yes,
I know you would like that.
And that's square root of 156.
Ms. Powell, your computer runs so slow. Okay. That's not perfect, Ms. Powell, but there you go.
Okay. Now, number line, yours stops at 20, but this has got to go to 25.00006. So you probably have to extend out your number line a little.
So we're going to extend it out here just a little bit. Okay, and so that's going to be 21, 22, 23, 24, 25, and then there's 26.
So if it's 25 point something, then it's got to be past the 25 to the right, because the farther the number is to the right, the bigger it is. And 25.0006 is bigger than just plain old 25.
So it's just barely over 25,
barely
though, right?
over 25.
So we're going to put it about right there. And for some reason, Ms. Powell, it did not change colors. I don't know why it didn't do that. But let's try it now. There we go. And so that's 25 point, and it's 600 thousandths.
600,000.
Okay.
Okay, so now the next number has a whole number of 0.324. So it's got to be bigger than 0, but it never makes it to the whole number 1. So this has got to fall in between 0 and 1. And then you got to think in between 0 and 1 perfectly is 0.5. Was this greater than 0.5 or less than 0.5?
And that's exactly what I would be thinking, Miss Powell, is what is half? Well, half is 0.5, right? So 0.3 is less than 0.5. So that means if it's between 0, and again, my 0 is going to be down here. So if that's the case, then I know that this is going to be a little greater than that. And so maybe right in there, Miss Powell.
Yep.
I mean, I know that's just barely. And so we called that what?
0.324.
I'm going to put it above here. 0.324. Okay.
Okay, so then we've got to do the square root of 225. Now we found out that ends up being a perfect square. When you take the square root of perfect square, you get a whole number. So
and we love that. That gives me this nice little warm fuzzy feeling inside, Miss Powell, doesn't it? You?
No,
does
really.
it? You got it?
No.
What? No warm fuzzy feeling, Miss Powell?
Just makes it easy to plot.
Makes it easy to plot.
Change your color. Ooh, I like purple.
I was on purple. You said we have to change the color.
Make it be a little lighter purple.
No, I'm sorry. I'm going to have to change the color. Okay, so 15, right?
Right.
Okay, so 15, right there on that spot.
15, the number that it was originally was square root of 225.
And I think that's important that you put the original number, especially when you're ordering like for K-Prep test or something like that, don't you, Miss Powell?
Yeah, because that's what they're asking you to figure out. Now, this is where it's going to get kind of hard because you've already got a point that's close to this one. It's 0.57 repeating.
Right.
So we'll say it's about 0.6. So this is going to be a little bit past a half. And you already had the 0.34. So pretty much how you're going to have to draw it is pretty much kind of close right there at the edge.
So
kind of too far over.
Well, I'm gonna get as close as I can, just right in there, Miss Powell. And again, my original number is what?
0.57 repeating.
So 0.57.
And the 5 and the 7 are both repeating. Okay. Now pay attention that I did not say it's 57 hundredths.
Right.
As soon as I say 57 hundredths, that should tell somebody that the 7 is in hundredths place and it terminates. Well, it doesn't. So they're really not a really good way of saying it other than 0.57 with a bar over the 5 and the 7. Do you know of a better way of saying it? Other
than the real name of the bar that's over it?
What's the real name of the bar?
You mean Miss Powell does not know the real name?
It's called a repeating bar.
No, it's got a name to it.
I have no idea.
I know what it is, and I'm not going to tell you because I want you to have to look it up. You get bonus points in Miss Powell's class if you look it up. It has a name, starts with a V, okay?
A vector?
No, Miss Powell, you do not know it. Don't try to guess. Aren't Miss Powell's wanting to go swimming here? You guys can't see it, but it's clouding up outside. Miss Powell's not got a lot of swim time left.
Yeah, okay, we got to go swimming.
Okay.
So 2.6, I'm going to ignore all of these other representations because even 13/5, I'd have a hard time figuring out where on the number line. So they already give me this decimal. So 2.6 is going to be a number bigger than 2, but less than 3.
So it's bigger than 2, but less than 3. But where does it fall? If it's 2.6, is that bigger than 1/2?
Yes, it's bigger than a half.
It's bigger than 1/2.
So it's going to be closer to the 3 than it would be for the 2. But not by much.
Not by much.
Almost in the middle.
So I think I've got a little orange here, Miss Powell, and I'm going to make that as 2.6. Okay.
Okay, the last one was 4.096746 ...
Now remind us again what those dots mean, Miss Powell.
This means that this never stops.
Right.
But they did not put that bar that starts with B. Remember
It's
what was it?
That's right. It was called a V,
Yeah.
but she doesn't know, so she was trying to trick me into telling her. I'm going to make her Google it because I know something that she doesn't.
Yeah, I don't remember even learning that.
Yeah, that's because I'm smarter than Miss Powell in
Okay.
this capacity.
So this doesn't repeat and it goes on forever. So if it's a non-terminating, non-repeating decimal, it's irrational.
Right,
Which meant we can't write it as a ratio, which still isn't that big a deal because I like the decimal.
right.
So what's confusing about numbers sometimes to students, every number in the whole wide world has a decimal representation, even 15. You may argue like 15 doesn't have a decimal. It does because you can write it as 15.0.
Right.
So every number has a decimal representation, but again, not every number has a ratio that it can be represented by.
And those irrational numbers, you think of the most famous one, which is pi, it's non terminating and non repeating. So that means it's just going and going and going and going. We don't know the exact decimal representation, but we approximate it like this one is 4.09. So, Miss Powell, it's just a little over 4, right?
Right.
So I've got to try to find another color. Miss Powell, she's big on these color things. I don't understand what that is, but I know that
You're
for some
picking
reason.
very ugly colors. Ooh, that's pretty.
Now,
yeah,
you like that?
Yeah, I like that.
Okay, so I'm going to go a little over 4 because it's 4.09, and so I'm going to get it real close to 4 here, just for Miss Powell. And I'm going to put 4.09.
Now, if you really wanted to be kind of lazy, you could just put dot, 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 because it went on forever.
I am putting dot, dot, dot.
Yeah, but you left off the other digits. And really, in that case, it's okay. It's not a repeating decimal, and you're just saying that it goes on forever and ever. So
Miss Powell's just doing that because I know the name of the line that's over top of it, and she doesn't. So
I think you're making it up.
I'm not making it up. Just as soon as this is over with, and I might even whisper, you cover your ears, I'm going to tell everybody what it is. She's trying to Google it right now, okay? It's called a vinculum, okay?
A vinculum.
Yeah. Okay, so that is how you order rational and irrational numbers on a number line. And hopefully you guys have that down and we will be reviewing it in class. So for Miss Powell, I'm Mr. Corbin, and we will see you next time.